Hi everyone, welcome back. And today first it's midnight, my neck of the woods, almost 1 a.m. And I thought I would squeeze this episode in as I'm on my way to see my parents in Vancouver. And um, basically just wanted to share a AutoCAD program that I designed, built, put together. It's always kind of been a dream of mine to create my own AutoCAD program. And the objective of this episode is basically to show you that you could do it with generative AI today. You could essentially build a program that allows you to design three-dimensional objects and just import those and print them on your 3D printer. I'm going to show you the one that I built. This episode is not about going into the science of gears. It is essentially just to show you that uh, what what a good, not perfect, nothing is ever perfect, but a good made to measure CAD program looks like. So I've actually built here um, this, which is a differential gear, and this was created with this program. So it works very well. You can even hear the noise, the grinding noise. That gives it like a little bit of that excellence. Yeah, looks pretty cool. We got some corner brackets here, obviously the gears, and I'm going to show you the program. Let's just jump right to it. So here's the code. Essentially, it does have a lot of files, and let me just take a quick look here. So this one does have quite a lot of files. The idea here is basically, I will show you the side here. So we've got the main, which is the file that runs and basically connects to all of the other files. We have, for instance, bevel gears, compound gears. We have a design canvas. We have something which is the gear viewer, and this one actually shows the three-dimensional view. We have the helical gear. I'll show you gusset plates. We've got some physics engines, all the good stuff, shaft collars, rings. So let's basically just activate this, and I'm going to show you what it looks like. And here's the program. So the first thing I wanted to do when I first started is obviously make sure that, like any CAD program, we have the ability to zoom in, zoom out, and rotate our objects. In this case here, we're looking at the spur gear, and we also have some dimensions on the screen, which is what I wanted to have. It just makes it easier to visualize. So let's take a look at the drop down. And we have our spur gear, we have a helical gear. Just going to move them a bit to the side. We have bevel gears. Rack gears. We have our worm gears. It's actually a worm gear set. We have pulleys. Here's a ring gear set, which is actually quite nice. Now, the nice thing about this is you could animate it. So I've added animation, and we could do a slow animation. We could do a normal. We could do it very fast. And we can stop it. We have the external version of it. We have a compound gear, stepped gear. Actually, let me go back to the compound gear. So this is the compound gear. The stepped gear. Here's a lever, which is pretty cool, which I've just shown you in the system that I printed. We have some plates. So you'll notice that you could change the size of just about anything. So here we could change the size, width, height, thickness, the hole spacing, the hole diameters. We have an angle plate, or also best known as or best used as a corner bracket. The gusset plate. And I've added some propellers also. And so we have one propeller, we have one with four. Here's a motor shaft, so you can actually connect it to your motor shaft. One thing I didn't add is to actually, or I think I may have it. And this is the thing about creating your own CAD program, is that sometimes you add a lot of functionalities. You might forget that that there is one or two functionalities that you have and you forgot you have it. But that's okay. Means you did a good job adding lots of functions. Um, so it's a shaft adapter. Basically, you can connect this to a motor. So if you've ever seen those hobby motors that have a metal shaft sticking out, basically this can connect to it. And we can add, so I have it here. We can add a screw. So here we go. Let me make this a bit bigger. And that screw allows you to basically connect it to the shaft. Um, we can also have a output side screw. Uh, this is a circular shaft, so we could also turn it into a cross shaft. So here's the cross shaft. So the circular shaft, you'll have the motor metal shaft going through here, and this here will adapt to your cross shaft. And yeah, so you could always undo. So undo button, you can reset, which will go back to its normal. Uh, we do have a shaft peg as well. So lots of cool stuff. I'll go back to the spur gear. Another functionality that I added is the bore type. So basically this is the bore hole. So we can have a cross beam. So here's the cross beam. We could add so we could change the width, height, thickness, any of those. We could have a shaft, so a matching shaft. And here we go. We can make it a lot longer. And all of these you could print. So basically you could export it as a STL or a 3MF. So you would just click, in this case it's 3MF, even though it says .stl. It's 3MF. I could export it as a .stl, and I could save it to my desktop. And you can import it to your 3D printer. So essentially, I could go to my Creality 3D printer. I'll import it. These are some part of the mechanism that I created that I've just shown you. This is the gear. And I could, so here we go. This is the gear. I could slice the plate and get it ready for printing. And I could export the shaft as well. So this will export just the shaft, the basically the cross shaft. And you can, again, export it as .stl or .3mf. I have the documentation, basically what the big difference is between these. Ideally, you want to just export it as .3mf because that is a lot more precise of a print, especially when you're printing small objects. I'll show you the rest here. So we can add let me go back to the circular. So here's the circular one, a circular shaft. Now we can add a stopper head to it. So that's pretty cool. And again, you could change the size of just about anything. We could add a shaft collar. There's the shaft collar. And I can add screw holes on the shaft collars. There they are. Let me just animate this for a bit because it's pretty cool. What else? So the collar, we can have a friction fit or a sliding fit. So basically you want it to just slide in, or you want it to be a little bit tighter, so it's going to be friction, which is always better. You can of course glue these as well. Uh, we can also have a shaft adapter. Basically this was the one for the motors. I'll remove that for now. And you can add a mating gear as well. So here is the mating gears. And there we go. So essentially you could print a whole bunch of shafts and they will go, they adjust automatically in size. So if I change the size, let me just show you here. If I change the size of the gear, the shaft and everything else, uh, basically, well, it would be more the shaft diameter. So if I change the shaft diameter, you'll notice that the circular holes in the gear change as well. So essentially they all adapt to each other. What else can I show you here? So we can create a 2D and a 3D. Oh, by the way, the mating gear. I could change sizes for the mating gear. So that's pretty cool. You could change the print quantity of how many you want to print. You could also, if I reset it, you could also set a screw hole. So let me show you what that is. So here we have the gear, and I could add a 2mm screw as a screw hole, which means that, by the way, I can reduce the hub depth. So here is the screw hole, and I can reduce the shaft diameter as well. And that allows you to basically have a more, um, a better hold on the shaft. So essentially, if you add a shaft through it, it's going to connect and basically connect to the shaft, the screw, and yep, it's one way to really set it properly. And again, you have all the dimensions. So lots of stuff that you can do. One thing that I wanted to do is this is a beam builder, a connector beam builder. So I can have a straight beam. Let me just, so if you increase the number of holes, you increase the length of the beam. You could actually reduce the length. You could increase the height, width, bore diameters. Again, export it. You can add a connector to the beam. So here we go. So basically, you have all kinds of other beams that you can put. You have an L beam. Let me just remove the connector. You have the H beam, a square beam, and you could add matching beam pairs. Another thing is you could create a 2D to 3D assembly. So this is pretty cool. Let me show you how this works. I could add a spur. I could add actually a straight beam, and then I could add a circular shaft, and I'm going to move it. Now I want it to be on top. So this is two dimension here. It's basically just to have a good perspective, and the 3D will allow you to see how it actually looks from all angles. So here we've added the shaft, and then I'm going to just add a spur gear, which I want it to be on top of that as well, right there. Now let's see if we transform it to 3D. What do we have? So here we go. We have our beam, our shaft, and our gear. One thing I should have added here is to center it. So that would just be a function to basically just put this in the middle so it's easier to rotate. But essentially, here we go. So it's, basically, you could add any of your gears that we've seen, any of the beams that we've seen, and different types of connectors, which are the shafts, the collars, the levers, the propellers. So we could add those there. Um, Life 3D is something that I'm working on. Now here's the physics. So it's a physics engine, and you can actually also get it from the bottom. So basically, where it says physics calculator. Ideally here, what you want to do is basically, and one of the things I'm going to add as well is a how to use it, basically how to use the program. So that's going to be a function at the top here. I'm sorry, I did not add this um, in this app here, but I will add it so you'll have it when you download the Python code. So essentially, what is this? If you're going to add a motor, so one of those hobby motors, you're going to enter the RPM for the motor. So let's say you're buying a motor from Amazon. It will provide you with the following details. It will provide you with the speed, the voltage, the horsepower, um, and ideally, once you enter all of these in, you can pretty much choose. Uh, so you have different stages. So ideally, you'll have the spur gear, or if you want helical gear, and these are the teeth for the drive, how many teeth you have, um, your face width, the size of the module, um, and essentially it will calculate and provide you with the stress, um, power out, power in, basically what type of torque you're going to get. So pretty simple to use. And basically at the bottom, you also have a full synopsis of everything. So the gear ratio, assuming it's a 1-to-1, as in this case, so that's the standard generic one, basically. And you could change the gear, the ratio of the gears. So if you add basically, so you have this would be your first gear, and then you have a second gear. So stage one, you'll have the output, and so you have rotations per minute, output torque, power in, power out, gear train loss. You've got efficiency. This is interesting. The current drawn and mechanical advantage, total heat that it would produce in watts, and actually watts is kind of total heat. And you can also copy the full report to clipboard. So I'll add a how-to, basically how to use this, and yeah, pretty cool stuff. And the test. So let me actually close that. So we have example assemblies here. So we have the bevel gear differential. I did a test one as well. for various reasons. So here's the bevel gear differential that I printed, and here it is. This one does have some holes. There we go. Now, this one is with the pegs. You could see the pegs here. Ideally, you'll need to glue it, but I recommend using the one with the screw holes. So this one has the screw holes instead. Make this a little bit bigger, and you could see there you could see the screw holes. You've got the cross hub in the middle. So basically, one thing that I really like is to add explanations. So you are quite aware of what it is that you're looking at, and you can identify the parts and pieces. I kind of cheated a bit. Basically I realized that the colors, some of them I didn't add in the respective places, and essentially you'll check and see what works best for you. This is kind of a tricky one to put together. It does require some dexterity, and but at the same time, it I recommend once you have your screws through the uh, through the corner brackets, and that you've got the full integrity of the perimeter of the object, of the enclosure, that you then remove one bracket at a time and glue it back in with some hard cement. Don't use a glue gun because that it just dries very quickly and hardens, and it your parts will not be essentially smooth and connect properly flush with each other. So the other test, and I did not print this one, it is a warm gearbox. Essentially, the whole idea is for the warm gear in the box is that it reduces the speed, but it actually increases torque. So obviously a you don't want to put a warm gearbox for anything that would fly because it will reduce the RPMs. But essentially, this would be a good example, maybe a good school experiment for the younger ones to show a reduction gear, which reduces the RPMs, but it actually increases the torque. So when would this be good? Basically, it is good for lifts, pulleys, elevators, just about anything where you need to reduce the RPMs but increase the capacity of torque. This one here is more barren than the other one in terms of explanation, and ideally you could also add the dimensions on the screen. So again, that's it for this showcase. I recommend that you open it up, downloaded the folder, open it in your, in this case, I use Visual Studio environment, the VS Visual Studio as the environment. And as you could see, I use Claude as the Gen AI, which is just excellent. And this was created using prompts and Gen AI. Sometimes you might think you might need to fight with it, but just have a clear cut understanding, put it on paper, what it is that you want to design and your architecture. And that's going to help you a lot. So that's it. That's basically um, my show for for this episode. Boy, it is hot here. This is my shop, and I don't have cold air coming in this one. It's an older house, and basically, my dream is to someday actually have a shop, preferably air conditioned. And yeah, I hope you enjoyed this show. Do take advantage of this code, build on it, add additional functionalities, and I'm sure that you're going to enjoy it. Thanks for watching, and bye for now.